In this lesson, we will study angles measured in radian measure. We have so far studied angles in degrees or measured in degrees. So in this lesson, we will explore what does it mean for an angle to have radian measure. So let's start with the definition. An angle with its vertex at the center of a circle that intercepts an arc on the circle equal in length to the radius of the circle has a measure of 1 radian. Let's draw a picture of that represents these words. So here we have drawn an angle. Notice the vertex of this angle is at the center of a circle, and it's intercepting an arc. Here's the arc that the angle intercepts. Now you have to pay close attention to the following. This arc happens to be the same length, equal in length to the radius of the circle. And that's what it means for this angle theta to have 1 radian. An angle that is measured 1 radian means the angle has its vertex at the center of the circle and intercepts an arc that is equal in length to the radius of the circle. So then it follows that an angle of measure 2 radians must intercept an arc equal in length to twice the radius of a circle. All right, so this angle here, theta, notice again that its vertex is at the center of the circle. This angle theta is measured 2 radians because it intercepts an arc that is equal in length to twice the radius. So then an angle measuring a half of a radian must intercept an arc that is equal in length to half the radius. Now notice that if theta is a central angle, now remember that a central angle is just an angle whose vertex is at the center of the circle, like we've drawn over and over again. All of these are central angles. The vertex is at the center of the circle. So if theta is a central angle of a circle of radius r, like we've drawn each time, radius is r, and theta intercepts an arc of length s, right? Let's just call the arc length s, okay? Then the radian measure of theta is s divided by r. So you can confirm that for each one of these. This is your s value right here, right? In this first case, your s value, your arc length, happened to be the same as the radius of the circle. So if you divide the arc length by the radius, that's what it's saying to do. S represents arc length. Divide the arc length by the radius of the circle, and that ratio will be the radian measure of your angle theta. So watch this. R divided by r, right? The arc length divided by the radius. The arc length r divided by r is 1. R divided by r is 1. So therefore, theta is only 1 radian. Look at this. 2r, which is the arc length here, 2r divided by r would just be 2, right? 2r divided by r is 2. This radian measure of theta is 2. And then finally, 1/2 r divided by r is just 1/2. So the radian measure of angle theta here is 1/2. So then if we have an angle theta and it intercepts the entire circle, right? The angle theta intercepts an arc equal in length to the entire circumference of the circle. First of all, let us remember that the circumference of a circle is 2 pi r, right? So what we're saying is imagine angle theta, whose vertex is at the center here, intercepts an arc, right? Intercepts an arc that is equal in length to the entire circumference of the circle. In other words, 2 pi r would be the arc length. 2 pi r would be the arc length. So let's find that radian measure of angle theta. Now, the radian measure of angle theta is s divided by r. Remember, s represents the arc length that is intercepted, the length of the arc that's intercepted by our angle theta. And in this case, the entire circle is intercepted, so the arc length here is 2 pi r. And r is the radius of the circle, which I failed to label in my diagram, so this is still r, right, the radius of the circle. So when you find this quotient, the r values get divided out, and all you're left with is 2 pi radians. 2 pi radians. So what we just determined right now is that an angle that is measured at 2 pi radians is an angle that does one complete rotation. One complete rotation around the circle is 2 pi radians. Therefore, we have 360 degrees, which is one complete rotation, is equivalent to 2 pi radians. 360 degrees is one complete rotation, and that's equivalent to 2 pi radians. Which leads us to 180 degrees is equal to pi radians, right? If 360 degrees is 2 pi radians, then half of 360, which is 180, would be equal to half of 2 pi, which is pi. So 180 degrees, a straight angle, is equivalent to pi radians. So we have this equivalence that 180 degrees is equal to pi radians. If we divide both sides by 180, so look at this, divide both sides by 180, look at this equivalence that we have now. We would have 1 degree on the left is equivalent to pi over 180 radian. Okay, so this equivalence is really, really, really important. Or we can have, if we go back to this statement here, if we divide both sides, here, let me actually write it down for you. Maybe before I write it down, if I just kind of box this, okay, everybody? And then if I go back to this equivalence, 180 degrees is equivalent to pi radians, right? But this time we divide by pi, well, we would have a different relationship here. At this point, I'm going to start with the right-hand side here. Pi radians divided by pi would leave you with just 1 radian, right? 1 radian is equal to 180 degrees over pi. Okay. Now these equivalences are going to be very important to us when we start converting from radian measure to degree measure, or from degree measure to radian measure. Okay, these equivalences. So here we have it, folks. If you're trying to convert from degrees to radians, all you have to do is multiply degree measure by pi over 180 radian, and then simplify to convert to radians. So this is what you multiply. Notice this is a unit fraction. Pi and 180 degrees are equivalent, right? So this is like 1 equal to 1, right? It's a unit fraction. So you are not changing the original value of the expression, right? Because you're multiplying by a unit fraction. Now, this is for going from degrees to radians multiplied by pi over 180. If you're going the other way around, if you want to convert from radians to degrees, multiply by 180 degrees over pi. 180 degrees over pi. Okay, so once again, this first fraction that you're multiplying by, this first ratio, is from going from degrees to radians, and then you would multiply by this ratio if you're going from radians to degrees. For our first example, we will be converting from degree measure to radian measure. So the first angle they've given us is 108 degrees. Notice that 108 degrees is in quadrant number 2. We want to convert this degree measure to radian measure. So the first thing we're going to do is recognize which ratio we're going to multiply by. So we're going to, since we're going from degree to radians, we want to multiply by this ratio, pi over 180. So we've taken 108 degrees and we are multiplying by this ratio here, which converts it to radian measure, okay? That's why there's no more degree symbol here, because now once we multiply by this ratio, we are now in radian measure. All right, let's divide out by the GCF here. I believe the GCF here would be 36. So I'm going to divide or cross cancel by 36. So 36 will go into 180 5 times. And then 36 will go into 108 3 times. So then when I simplify, I get that 108 degrees is equivalent to 3 pi over 5 radians. Be careful with your arithmetic here and finding the GCF and find out what you're going to divide by. Here I found out that the GCF, the largest number that divides into 108 and 180 is 36. So I divided 108 and 180 by 36. You could have divided, 108 and 180 are both even numbers, so you could have divided by 2, but then you're going to have to divide by 2 again and again and again until you get something that is simplest form. All right, let's try another one. Here we have negative 135 degrees. This is in quadrant number 3. All right, so let us figure out what the radian measure of this angle is. Once again, because this is degree measure and we're converting to radian measure, we want to multiply negative 135 by pi over 180, and this is radian measure now, okay? Now, again, I don't have the degree symbol here on negative 135 because once we multiply by this ratio, we are in radian measure. All right, let's find the GCF between 135 and 180. All right, the GCF between 135 and 180. Notice that 135 ends in a 5 and 180 ends in a 0. So you can divide both of these by 5 if you'd like. But you'd have to keep on going until you get something of simplest form. I believe the GCF here is 45. 45 will divide into 180 4 times, and 45 will divide into 135 3 times. So that's what I'll show. Dividing by 45, 45 divides into 135 3 times and into 180 4 times. So then the final answer here in simplest form is negative 3 pi over 4 radians. Don't ever forget the units here. So this is in terms of radians, okay? So negative 135 degrees is equivalent to negative 3 pi over 4 radians. Let's do one more. All right, the last one that we'll do here is 325.7 degrees. Now, this is decimal degrees, okay? So we're going to get decimal radians. Notice that there are 4 significant digits here, so let's use the same number of significant digits for when we round for the number of radians. All right, let's go for it, folks. So let's go 325.7, don't write degrees, and then do pi over 180, and now we are in terms of radians, okay? So I'm going to write radians here. All right, so we're now in terms of radians, and we're going to use a calculator here, okay? So I want to be very careful when I multiply on my calculator. Do not use the approximation 3.14, the most common approximation for pi. Don't use that. Instead, when you're doing this calculation here, press the pi button on your calculator, the pi key. Okay, press that button on your calculator instead of punching in something like 3.14, because then we're going to be off a little bit. So do 325.7 times, press the pi button, and then divide that product by 180, and let's round to 4 significant digits, and we should get 5.685 radians. All right. Very good. 325.7 degrees is a little bit less than 360 degrees. So this is definitely in quadrant 4. And 5.685 radians is a little bit less than 2 pi. Because 2 pi would be 2 times, well, it'd be approximately 2 times 3.14, which is approximately 6.28. So we know that this is also in quadrant 4 as well. All right, so we're pretty good here. All right, cool deal, everybody. Now let's convert the other direction. Let me give you radian measure, and you do convert to degree measure. All right, let's do this. Convert each radian measure to degrees. Now, let me say something. I did not write radians. I didn't write out the word. So this is very important. Whenever the unit is not given, neither degrees nor the word radians, then we always assume that we're talking radians. Let me say that again. There is no degree symbol up here, and also there is no word that says radians. So you and I must assume that when neither the degree symbol is used nor the word radians, then this angle must be in radian mode or radian measure. That's very important. Okay, notice that 11 pi over 12 is almost 12 pi over 12. So in other words, this is almost 1 pi. Remember, 1 pi is equal to 180 degrees. So this is almost 180 degrees. Keep that in mind. So that puts us in quadrant number 2. All right, so let's multiply by the correct ratio. So what I'm going to do is I'm going to take my radian measure, 11 pi over 12, and I'm multiplying by this ratio, 180 degrees over pi, like that. Okay, everybody, so I hope you can see what I see here, and that is pi divides out with pi, right, of course. And then 12 divides into 180, right? 12 divides into 180 exactly. Let's see, 12 goes into 18 once. And you'll have 6 left over, 60, so 12 goes into 65 times. So that's 15 times. So all you have to do now is multiply 11 by 15, and that's how many degrees you have. So this is equal to 165 degrees, which agrees with what we said earlier. We said this is an angle in quadrant 2, and so is 165 degrees. All right, cool deal. The next angle is negative 7 pi over 6. Notice that this is in quadrant number 2, right? So remember that this is a little bit more than negative pi. And negative pi, you'd have to open up clockwise. Negative pi is negative 180 degrees. But this is a little bit more, actually a little less than that. It's negative 7 pi over 6. So it would actually take you all the way to quadrant 2. All right, cool. So let's go ahead and do this. So we're going to multiply negative 7 pi over 6 radians by 180 degrees over pi. And so we can see here that pi divides out with pi, and 6 goes into 180 3 times. So then negative 7 pi over 6 is equivalent to negative 210 degrees. That looks a little funny here. Let me move this negative sign here. All right, so negative 210 degrees. And this is definitely in quadrant number 2. All right, let's do one more. Now notice the next angle is negative 2.92. Now you do not see a degree symbol up here. You also don't see the word radians. So this is what I mean. When they give you an angle like this, where neither the degree symbol nor the word radian appears, you must assume that this angle is given in radian measure. Okay, that's very important. All right, so we're going to convert radians to degrees. Here we go. So we're going to take negative 2.92 radians, and we're going to multiply by 180 degrees over pi. Now, they gave us an angle that is in decimal radians, so we're going to get an answer that's in decimal degrees. Now, it's very important that we punch this in correctly into our calculator, okay? So punch in negative 2.92, multiply that by 180, and then divide that product by pi. But remember, when you press pi, don't use any approximation for pi. Actually click or push the button that has pi on it, okay? So this number, negative 2.92 times 180, and then divide that product by pi, and you should get approximately equal to, now keep in mind here, that we have 3 significant digits, so that's what I'm going to round to. So this is approximately here negative 167 degrees. Okay, that's what it's approximately equal to. All right, cool deal, everybody. Okay, everybody, I have our special angles, 30, 45, and 60 degrees, and then I have our quadrantal angles, 0 degrees, 90, 180, 270, and 360 degrees. Now, this whole column is degrees. All to the right, everybody, will be I have radian our measure. Special angles, the exact 30, radian 45, measure, and then 60 the approximate degrees, and then I have measure. Our quadrantal right, first things first, 0 degrees, 0 degrees, 90, 180, now this one's probably going to be the easiest. Degrees. Now this whole column is degrees. All to the right will be radian measure. I'll give the exact radian measure and then the approximate radian measure. All right, first things first, 0 degrees. Now this one's probably going to be the easiest. 0 degrees in radian measure is just 0 radians, and the approximation of that number is just 0. Okay, that's the easier one. All right, 30 degrees. If you convert 30 degrees to radian measure, this is very important, everybody, that you get this equivalence. 30 degrees is equivalent to pi over 6. Pi over 6. Now the approximate radian measure there is 0.52 radians. So it's very important that you understand that 30 degrees is approximately equal to half of a radian. Let's go to 45 degrees. In radian measure, the exact value would be pi over 4. Now the radian measure there as an approximation is approximately 0.79. Okay, 60 degrees as an exact value here would be pi over 3. Okay, and in radian measure, it'd be 1.05. So notice that 60 degrees is about 1 radian. 60 degrees is about 1 radian. That's very important. All right, let's keep going. 90 degrees is exactly equal to pi over 2. Pi over 2. And that is about 1.57 radians. Please notice that pi over 2, which is 90 degrees is about 1.57 radians. So about 1.5, maybe about 1.6 radians. Okay, that's very important. 180 degrees is exactly equal to pi, right? And pi is about 3.14. Okay, 180 degrees is about 3.14. Okay, and finally, or 2 more, I guess, 270 degrees is 3 pi over 2, 3 pi over 2, and the decimal approximation there is 4.71 radians. Finally, 360 degrees is exactly equal to 2 pi, right? We talked about that earlier, which is about 6.28 radians. One full rotation is about 6.28 radians. Okay, everybody? That's very important. So from this point forward, it is very crucial that if I say pi over 3, if someone says pi over 3, you know that to be 60 degrees. If someone says pi over 6, we all know that we're talking 30 degrees. If we say 3 pi over 2, we all understand that to be 270 degrees. And it's a very good idea to know the common approximation for these radian measures. Before we end this lesson, I want to draw you a rough circle, obviously here, very rough. But I want to draw these angles that we're discussing, the special angles and the quadrantal angles, and with their equivalences, both in degree measure and radian measure. So let's start with 30 degrees. So this would be approximately a 30-degree angle here from the positive x-axis to this green ray. That would be approximately 30 degrees. And 30 degrees in radian measure would be pi over 6. So this would be pi over 6. All right, let's go to a 45-degree angle. A 45-degree angle would be basically splitting this quadrant in half, okay? Remember, this is just a sketch. So this is a 45-degree angle here from the positive x-axis up to this green, the second green ray. So this would be 45 degrees. half of 90 degrees. And in radian measure, this would be pi over 4. All right, let's go for 60 degrees. 60 degrees is about right here. 60 degrees. And our radian measure for 60 degrees is pi over 3. All right, so these are our first angles that we're going to talk about. These are actually the special angles is what I wanted to say, your special angles. Now, we can't forget 0 degrees, right, everybody? I kind of did, actually. 0 degrees is here, of course. This is a 0 degree angle. All right, 0 degrees. And, of course, as far as radians, that would be 0 radians. All right, let's continue. 90 degree angle would be right up here, the positive y-axis, right? So this would be 90 degrees, if I can fit it right there at the top of the screen. And the radian measure for 90 degrees is pi over 2. All right? All right, let's keep going. So I'm going to give the next 3 angles at once here. So here would be 120 degrees. And then this would be 135 degrees, and then this would be 150 degrees. Let me label those for us. Okay, so this is 120 degrees here. This is 135 degrees, and then this is 150 degrees. Remember, these are our reference angles. 30 degrees, 45, and 60 degrees are our reference angles. 120 degrees is the angle in quadrant 2 whose reference angle is 60 degrees. 135 degrees is the angle in quadrant 2 whose reference angle is 45 degrees. I know that because from 135 degrees to 180, right, is 45 degrees. That's how we determined or defined reference angles in an earlier lesson. From 120 degrees to the negative x-axis here is 60 degrees. That's how I know that the reference angle for 120 degrees is 60 degrees. 150 degrees is just 30 degrees away from 180 degrees, so the reference angle would be 30 degrees. Okay, now let's give the radian measure for each of these. Now, remember, we know how to convert from degree measure to radian measure and from radian measure to degree measure. So if you convert 120 degrees to radian measure, you would get 2 pi over 3. 2 pi over 3. If I can make that a little neater for you, 2 pi over 3. That's just a little neater. 2 pi over 3 is equivalent to 120 degrees. Next is 135 degrees, which is 3 pi over 4. 3 pi over 4 is equivalent to 135 degrees. And finally, 150 degrees is equivalent to 5 pi over 6. I'll write it right underneath it here. 5 pi over 6. And then our next quadrantal angle, we have 2 quadrantal angles so far, 0 degrees and 90 degrees. But our third one would be 180 degrees. This would be 180 degrees. And we learned that 180 degrees is equivalent to pi. Okay, is equivalent to pi. All right, so that's what I want to continue doing for quadrants 3 and 4. So let me give you those now. All right, everybody, we got 210 degrees, 225 degrees, and 240 degrees. We got 270 degrees, 300 degrees, 315 degrees, 330 degrees, and of course 360 degrees, which is coterminal with 0 degrees. Now, 210 degrees is very important, a very important angle for us because the reference angle would be 30 degrees, one of our special angles. 225 degrees would be very important to us because its reference angle is 45 degrees, the other special angle for us. 240 degrees, the reference angle would be 60 degrees. 270 degrees, of course, is quadrantal. 300 degrees, its reference angle would be 60 degrees. And then 315 degrees, its reference angle would be 45 degrees. And finally, 330 degrees, its reference angle would be 30 degrees. And of course, we mentioned 360 degrees is quadrantal. All right, so what we want to do now to wrap this up is give the radian measure for each of these angles here. And remember that we know how to convert from degree to radians. We were doing that in an earlier lesson. So 210 degrees is equivalent to 7 pi over 6. 7 pi over 6. 7 pi over 6. 225 degrees is 5 pi over 4. I invite you to convert these on your own and don't just take my word for it. 240 degrees is 4 pi over 3. 270 degrees is 3 pi over 2. If I can squeeze that in there, right? This says 3 pi over 2. 300 degrees is 5 pi over 3. 315 degrees is 7 pi over 4. 330 degrees is 11 pi over 6. And then 360 degrees is equivalent to 2 pi. All right, so some people would call this a unit circle. This is not necessarily the unit circle. In order for this to be the unit circle, the radius would have to be 1, and I did not specify that the radius is 1. If I make the radius 1, then this would be the unit circle, okay? And we'll eventually get there in further lessons. So we have every angle that is of importance to us with their degree measure and radian measure. All right, so what we're going to do here is do the last example, which is example number 3, and it's going to have us referencing that circle with all of our angle measures, okay? So make sure you keep that handy. All right, find each function value, each exact function value. Cosine of 5 pi over 6. Let's look at our circle, okay? I'm going to bring it back here. 5 pi over 6 is what I'm looking for, and I have found it. Have you guys found it? 5 pi over 6 is here. This is 5 pi over 6. Notice that it's in quadrant 2. So therefore, cosine of such an angle will be negative. Our answer will be negative. And notice that 5 pi over 6 is equivalent to 150 degrees. 150 degrees. So let me go back to my problem here, and I am going to say that cosine of 5 pi over 6 is exactly equal to cosine of 150 degrees, right? Is exactly equal to 150 degrees, which is equal to, now using a reference angle, the reference angle for 150 degrees would be 30 degrees. So it's going to be the opposite of cosine of 30 degrees. The reason why I have opposite is because this angle here, 5 pi over 6, is in quadrant 2 and cosine is negative in quadrant 2. We all know, hopefully, that cosine of 30 degrees is root 3 over 2. So our final answer is negative root 3 over 2. That's what cosine of 5 pi over 6 is. All right, let's do another one. All right, we have cotangent of 3 pi over 4. So let's go to our circle, right, and find 3 pi over 4. Now 3 pi over 4 is here in quadrant 2, right, quadrant 2. 3 pi over 4 is equivalent to 135 degrees. Now in quadrant 2, cotangent is negative, so our final answer will be negative. All right, so let's do it. So this is exactly equal to cotangent of 135 degrees. Now, because it's negative in quadrant 2, I'm going to say it's equal to the opposite of cotangent of its reference angle, which is 45 degrees. The reference angle for 135 degrees is 45 degrees. And hopefully you know by now that 45 degrees, cotangent of 45 degrees, is 1. So the final answer is just negative 1. That's the function value, the exact function value. All right, cool deal. Let's do one more. Secant of 5 pi over 3. All right, let's find 5 pi over 3. Looking back at my circle here, and I found it. 5 pi over 3 is right here. 5 pi over 3 is equivalent to 300 degrees, which is in quadrant 4. 300 degrees in quadrant 4. Now, I know my final answer will be positive because secant is positive in quadrant 4. I know that because secant is a reciprocal of cosine, and cosine is positive in quadrant 4. Don't forget, all students take calculus. So cosine and secant are positive in quadrant 4. All right, so then this is equivalent to secant of 300 degrees, right, is what we just found. And our reference angle here will be 60 degrees. So this is equivalent to secant of 60 degrees. I don't need a negative sign here because in quadrant 4, we're positive, so we're fine. And secant of 60 degrees, if you forgot what that is, no worries. Secant of 60 degrees is equivalent to 1 over cosine of 60 degrees. So maybe you forgot what secant of 60 degrees is, as long as you remember what cosine of 60 degrees is, which is 1/2. So it's 1 over 1/2, which is just the number 2. So 2 is secant of 5 pi over 3. All right, good job, everybody. We covered a lot in this lesson. We covered the definition of radian measure. Please review that. And we know how to convert from degree measure to radian measure, how to convert from radian measure to degree measure. And we also know how to locate a certain angle on the circle, all right? And to find exact function values. All right, this is the end of this lesson. I'll catch you later.